In our lesson today, toda kutaura about something called a discriminant. So we have to first define what a discriminant is. Saka, our first point is going to be quadratic equations are solved using either the method of factorization or the method of the quadratic formula. This we should know already. Saka, a discriminant is a tool used to draw up a conclusion on the nature of roots or solutions. So let us kick off. We learned from O level that we use a quadratic formula. So this is a note you have to write in your notes to solve quadratic equations. Saka, primarily our primary method is factorization because of how easy and convenient it is. But in some cases we use the quadratic formula. So what is this quadratic formula? So this is a review of what you should know already. Saka, a quadratic formula, it is written like this. X is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Saka aya ndo manyorero ataita ku O level, the quadratic formula. Now we should know something. What you should know is this. The quadratic formula can be expressed like this. Can be expressed like this. Ngati say this yacho pasi. Tinogona kuinyora takati x is equal to minus b plus or minus the square root of d over 2a. Saka togona kuinyora yakadai so. Where d is the discriminant. Saka d iyo ndio ingeri discriminant. What does this mean? Therefore, the discriminant d is equal to b squared minus 4ac. Saka amadzangu chinonzi discriminant ndi b squared minus 4ac. Kana kuti zvinenge zviri pasi pe the square root inside the quadratic formula. That is what a discriminant is. Saka a discriminant inenge irichi b squared minus 4ac, and let us bracket this. This is very important. Now what does this discriminant tell us about a quadratic function kana a quadratic equation? So taona kuti that is the discriminant. What then are we going to say? At this particular stage, much emphasis is placed on the discriminant. Why is that so? That is the value under the square root sign sekutsanangura kwataita. A discriminant is a tool used to draw up a conclusion on the nature of roots or solutions. Saka, this is a notable effect. Very important. A discriminant is used, apawati it is used to draw up a conclusion on the nature of roots. Saka, a discriminant is used to determine the nature of roots. I want you to underline pakanzi nature of roots. Chii chinombonzi ma roots. the roots of a quadratic equation are the solutions of a quadratic equation. Saka the roots of a quadratic equation are the solutions of that quadratic equation. Let us digress a little and explain this. Saka taona kuti under the square root sign inside a quadratic formula tina b squared minus 4ac, which is called the discriminant kana kungoti capitalized d. Ndokutsanangura kuti a discriminant is used to determine the nature of roots. Iyo maroots acho chimbori chi maanswers atinowana kana tikasolve a quadratic equation. So remember taiti tikasolve a quadratic equation taizowana answer yakaita seizvi: x is equal to 2 or x is equal to minus 3. These are just examples. X is equal to 2 na x is equal to minus 3. They are called the roots of the quadratic equation. Maanswers atinowana tikasolve a quadratic equation anonzi maroots. Saka kuti to understand the nature of these roots, and we are going to put context to the word nature manje, we are going to use the discriminant. So when we keep on learning about it, it's going to become a little apparent. The discriminant gives birth to 3 conditions outlined immediately below. Saka, the discriminant, how does it outline the nature? So panapa, let us write this, not pano, let us write down this subheading using the discriminant. Using the discriminant. So how do we use the discriminant? The discriminant gives birth to 3 conditions outlined immediately below. Saka the first condition ndeyekuti if b squared minus 4ac is equal to 0. Chichinoitika kana discriminant yedu iri 0. Ngatiti tanyora a quadratic formula. Tanyora a quadratic formula takuishandisa kuda kusolve a quadratic equation. Then we discover kuti pasi pe the square root sign pana 0. Kureva kuti our discriminant is 0. This condition gives rise to 2 identical roots or solutions, commonly known as one repeated root. Saka, if this situation happens, maybe let us write it like this. Tikati if b squared minus 4ac is equal to 0, what happens? Chekutanga ndechekuti we have repeated roots. And kana tichiti we have repeated roots, what exactly do we mean? This gives rise to 2 identical roots. That is, we have 2 identical roots. We have 2 identical roots. And these roots are the ones which are called repeated roots. Saka panapa, let me put an illustration. If you remember from your O-level, for my calculator, mchishandisa the quadratic formula or even factorization, mune situation yekuti answer yenyu aizobuda yakadai so. Inogona kubuda, for example, yakati x is equal to 3 or x is equal to 3. Saka situation yataizoti x is equal to 3 or x is equal to 3, this particular situation, taigona kunyora takati x is equal to 3 twice. Ndiko kuti repeated root. Saka kana discriminant b squared minus 4ac equal to 0, we have what is called a repeated root. 2 identical roots occur at the same point of intersection of a curve and a tangent, as shown below. So let us write it down and do the showing. So our next point is going to be two identical roots or solutions. They do occur at the same point of intersection of a curve and a tangent. Now this, that which we have written down, it will be more like this. So we have a curve and we have a point of intersection with a tangent. So a tangent is just a straight line inoguma a curve at only one point. So it's like this. So this is our tangent. That is our curve. And that's the one repeated solution. Like this. Saka topic yatrukita inoda muine a solid understanding of quadratics seku O level. We did a lessons a quadratics seku O level. And if you feel the need to revise that, you can tell us in the comments or on our numbers and we make that link available. Because I am assuming a lot of stuff here, assuming that you still have quadratics seku O level in your minds. So this is what happens when the discriminant is equal to 0. If the discriminant is 0, the quadratic formula is then reduced. So let us dramatize this. Saka pano trikuti when the discriminant is 0, when the discriminant is 0, remember that x is equal to chi minus b plus or minus the square root of b squared minus 4ac over 2a. Saka kana discriminant is 0, so pana patri kuti if b squared minus 4ac in our discriminant is equal to 0. But I also think it would have been more helpful than what I saw. Tainyora instead as x is equal to minus b plus or minus the square root of d over 2a toti if kana kuti when d is equals to 0. It makes it a little easier. But kuinyora takadai so tichinyora the whole expression is important because you are going to see its applicability. Saka let us continue like this. So if b squared minus 4ac is equals to 0, zvakuchireva zvino kuti x is equal to minus b plus or minus the square root of what? 0 over 2a. But the square root of 0 is evidently and obviously 0. Kureva kuti x will just be equal to minus b over 2a. So this is the situation which happens when the discriminant is 0 and when we have a situation of repeated roots. But some might want to have the full working panapa. Full working in gechiti x is equals to minus b plus or minus the square root of 0 is 0 over 2a. Therefore, x is equal to minus b plus 0 over 2a or minus b minus 0 over 2a. Evaluating this, tichangona kuti x inge equal to minus b over 2a or minus b over 2a. Saka by that tadzokera apo. Murikushona. So that's the situation when we have repeated roots. Takuratidzai graphically chichinenge chichiitika curve redu rinenge richinosangana netangent on one particular point. Point yacho ndo repeated roots. Takuratidzai mathematically kuti chichinoitika ku formula. The formula is just reduced to x is equal to minus b over 2a. Let us go to situation number 2. Situation number 2 is if we have the discriminant b squared minus 4ac being greater than 0. So what happens if the discriminant is greater than 0? So our first note, this condition leads to two different or distinct roots. Sapanapa we have two different or distinct roots. This is what happened. It implies that the two graphs intersected two different points. Saka graphically, ndozvinoitika. We have our curve. Then we have a line. Saka curve redu neline zviri kusangana pa two distinct different points of intersection. Saka izvi ndezvichiitika kuti these are now the two different routes. Saka tenge tichiti this is the first route and that is the second route. This is a curve, cannot just a line. No, kuti a line is also called a curve in other circles, and that's a curve like this. Saka situation iyi ndiyo yataisangana nayo kazhinji pataisolva ma-quadratic equations. Pataiwana ma-answer 2 akasiyana, x is equals to 1 or x is equals to minus 3, x is equals to 8 or x is equals to minus 2, x is equals to 2 or x is equals to 5, etc. Zvenge zvichireva kuti we have two distinct different routes, and graphically speaking tiri kuti our curve and the line intersected two different points of intersection. Saka let us see what happens geometrically or what happens to the formula. Assuming that the discriminant is, for argument's sake, 9, the quadratic formula reduces to that. So discriminant ikava greater than 0. Zvinoreva kuti inenge iri a positive number. So kana discriminant, maybe let us write this. When the discriminant, saka ndakunyushandisa d, so when d is greater than 0, this means d is a positive number. And positive numbers have roots, and positive numbers actually have square roots. Let me put an example panapa for argument's sake. An example, and when the discriminant b squared minus 4ac is equal to 9. Therefore, x being equal to minus b plus or minus the square root of b squared minus 4ac over 2a, it then means x is equal to minus b plus or minus the square root of 9 over 2a, which means minus b plus or minus 3 over 2a, which means minus b plus 3 over 2a, or minus b minus 3 over 2a. Saka ino indo inenge first root, cannot first solution. Ino inenge second root, like that. So that is very important, and you are going to see its importance quite soon. Let's go to situation number 3. If the discriminant b squared minus 4ac is less than 0. What happens in such a case? Saka, this condition gives rise to non-existent roots. Diagrammatically, the two graphs do not intersect as shown. So, truth panapa, we have no roots. And Why is it so? Because until D becomes negative and we don't have, for now ngatinyorere chidai, so we don't have square roots for negative numbers. Murukuzona. An example would be kana discriminant yedu b squared minus 4ac iri equal to, for example, minus 9. Saka panapa tinge takuti x is equal to minus b plus or minus the square root of minus 9 over 2a, of which part inoi is square root of minus 9, it's non-existent. Saka we have no roots. Because we have no roots, diagrammatically zvinge zvakadai so, we have a curve, then a line. Asitombogumani sase zvakadai so, hatina maroots. Chinonzi root or a solution, this is the point where we have curve yedu which intersecta neline. Saka kana tisina maroots zorova kuti the two graphs, curve neline, should be disjoined. Mazvona sezvatakuratidzai apo. Something to note: to use any of the three conditions outlined above. So the first condition, the discriminant was equal to 0. The next condition, the discriminant was greater than 0, meaning it was positive. Then the last condition, the discriminant was less than 0, meaning it was negative. To use these three conditions outlined, one has to combine the two equations in question and reduce them into a general quadratic equation. It is from this general equation that one can pull out A, B, and C. Chiri kutaurwa pano masovhero ataita zvinhu tichishandisa quadratic formula, how we did it. Conditions 2 and 3 make use of inequalities, and we have seen them greater than 0, less than 0. The nature of roots. Saka chiri kunzi nature yacho tikati repeated roots, it's a nature of roots kana discriminant iri equal to 0. Tikati distinct roots, two distinct roots, it is the nature of roots kana discriminant iri greater than 0. Tikati non-existing roots kana kuti non-existent roots. Sapana panga chitonzi ma non-existent roots. This is the case, this is the nature of roots kana discriminant iri less than 0. Mapaona. So the nature of roots is inspired by the location of the discriminant on the number line. A discriminant is either positive, negative, or neutral, that's 0. Below is a number line summary of conditions hinged to the discriminant. So let me just put it down so that munoinyora in your notes as some form of summary. So we have a number line. This is the number line. And of course, pakati pacho pano pana 0. Saka kunoku, the left of 0, we have negative values. The right of 0, we have positive values. Pana 0 pana apapa, tinenge tine two identical roots. Pana 0, we have two identical roots. Saka kana discriminant yedu iri equal to 0, ndozvirongotaurwa apa. Discriminant yedu b squared minus 4ac iri equal to 0, tine two identical roots. Then patiri kuti no real roots kunoku. This is a situation where discriminant yedu inenge iri less than 0. Then patiri kutaura about two different roots, cannot two distinct roots. Two different roots. This is a situation where our discriminant b squared minus 4ac is actually greater than 0. Saka kana discriminant iri less than 0 zvoreva kuti inenge iri negative. Kana iri greater than 0 zvoreva kuti inenge iri positive. And this word real is very important, but I won't explain it now. Muchazozoona patichaita anonzi complex numbers. Kuti maroots acho anenge aripo, but they are not real, because we cannot have a square root of a negative number. So this is what we wanted to learn today. I hope you learned something new. If you have questions, please use the comments section, don't hesitate. But if you want to ask us directly, or if you want to engage us on other business, WhatsApp us on this number. Kana muri muZimbabwe, it will simply be 071 521 3310. Thank you, take care, and muve nzwa rakanaka.